In this example, we will learn how to use Gaussian elimination method to solve the system of the matrix. First, we would like to write the system into the augmented matrix. You will observe that the third equation actually doesn't have z, so we just write the coefficient of z as 0. So the next step is we are going to change this augmented matrix so that it's in the row echelon form, where you can see the 1 on the diagonal from upper left to lower right and 0 below the ones. So our target is to change this into the row echelon form so that we can solve the system. So we start by interchanging row 1 and row 2. The purpose we interchange row 1 and row 2 is we want to change the first element in the upper left corner in first row to be 1. So we continue. Now we want to eliminate down first column by using 1 in the upper left corner to change all the terms or elements below 1 in column 1 to become 0. So the first step we need to do is we need to eliminate these two become 0. So we will use the element 1 in row 1 to change the first element in row 2 become 0. So what we will do is we multiply negative 2 with row 1 and then we sum it to row 2. So multiply negative 2 to row 1 and sum to row 2. So we have 0, 8, negative 3, and 58. We have to do for the whole row. Then we continue to change the first element in row 3 becomes 0. So we will just sum row 1 and row 3. So we will get a 0 here. So 1 is summed to negative 1, we get 0, and then we sum the rest as well. So now in the first column, we got 1, 0, 0. Next, we are going to change the second element in the second row to change it become 1. So I guess it's easier if we interchange row 2 and row 3 so that we can just eliminate this 8 easily. So interchange row 2 and row 3. So you see there's an 8 here. Actually it's very easy to change this element 8 becomes 0 since we have negative 2 at the second element of row 2. And then 8 is actually larger than negative 2 to avoid fraction. That's why we interchange row 2 and row 3 to eliminate down a column. So for row 2 here, we will multiply 4, we will get negative 8, then we sum to row 3, so we will get 0 here. So multiply 4 with row 2 and sum with row 3. Get 0. Multiply 4 with 1. Then we sum with negative 3. We get 1. Then we do the same thing. And then we'll get 2 here. So the last one will be negative 2. We need to change this negative 2 become 1. We are lucky enough because we have a 1 at the bottom of the third column, so we wouldn't have to correct it. So we just divide row 2 by negative 2. So if we divide row 2 by negative 2, so what we have here is 0, 1. 1 divided by negative 2, so we have negative half. Negative 14 divided by negative 2, we have 7. So row 3 is still the same. So now we have the matrix in the row echelon form. Next, we will use the back substitution to find the x and the y and the z values. So this is x, y, and z. So we will solve for the z first. It's very obvious. This one, for the first row, is x subtract 3y plus z equals to negative 28. Second row, y subtract half z equals to 7. Last row, z equals to 2. So it's very easy. We have z equals to 2 as our answer. So now we will use z equals to 2 we substitute into the second equation. So if we substitute into the second equation, so we will get y equals to 8. Finally, if we need to find x, we will do exactly the same thing. We will substitute z equals to 2 and y equals to 8 into the first equation. So we have x subtract 3 multiply 8 plus 2 equals to negative 28. And when we solve it, we get x equals to negative 6. So the solution set will be negative 6, 8, and 2.